Okay, welcome to chapter 3.2, parallel lines and transversals. Essential question, when two parallel lines are cut by a transversal, which of the resulting pairs of angles are congruent? So chapter 3.1 was two lines and a transversal, but now we're getting more specific, and the two lines that the transversal are crossing in this chapter are parallel lines. Okay, so what you will learn is how to use properties of parallel lines, prove theorems about parallel lines, and solve real-life problems. Okay, so we have four theorems using properties of parallel lines. So theorem 3.1 says corresponding angles theorem. If two parallel lines are cut by a transversal, so let's stop right there. This little red triangle here and this little red triangle here indicate that line P is parallel to line Q, and line T cuts through both of them, so the line T is a transversal. Then the pair of corresponding angles are congruent. So examples, in the diagram at the left, angle 2 is here, and the corresponding angle is 6, and they are congruent. Angle 3 is right here, and it is congruent to angle 7. The proof is exercise 36 on page 180, or example 36. Example exercise, not sure. But anyway, theorem 3.2 now states that alternate interior angle theorem, if two parallel lines P and Q are cut by a transversal T, then the pair of alternate interior angles have to be congruent. So angle 3 is going to be congruent to angle 6. Alternate interior, remember, are in between the two parallel lines and on opposite sides of the transversal, so 3 and 6. And angle 4 is congruent to angle 5. They're alternate interior angles as well. Okay? All right, next one. Theorem 3.3, alternate exterior angles theorem. If two parallel lines P and Q are cut by a transversal T, then the pair's alternate exterior angles are congruent. So angle 1 will be congruent to angle 8, and angle 2 would be congruent to angle 7. Alternate exterior angles are congruent. Finally, 3.4, consecutive interior angles, I also call same side interior angles theorem. If two parallel lines P and Q are cut by a transversal T, then the pairs of consecutive interior angles are supplementary. So in other words, angle 3, okay, and angle 5 add up to 180 degrees, and angle 4 and angle 6 add up to 180 degrees, supplementary. Okay, consecutive interior angles are supplementary. So those are the four theorems that come from parallel lines cut by a transversal. Okay, this is example 1, identifying angles. After this example is done, pause the video. You should be able to do problems 3 through 6 on your homework after that. The measures of 3 of the numbered angles are 120 degrees. The measures of 3 of the numbered angles identify the angles. So this is 120 degrees. By the theorems on the prior page, corresponding angles are congruent. So the measure of angle 5 equals 120 degrees. Vertical angles are congruent, so the measure of angle 4 is 120 degrees. And then I could do alternate exterior from the 120. This angle here and this angle 8 are alternate exteriors, so the measure of angle 8 equals 120 degrees. Or I could have gone 120 is congruent to angle 5 because they correspond, and then angle 5 and angle 4 are alternate interior angles, and then these coincide here. So they all are relative, even not even bringing in the fact that we have vertical angles. We could say this. So it's angle 5, angle 4, and angle 8 are the 3 angles that are also 120 degrees. Okay, example 2, using properties of parallel lines. After I do this example, you should be able to do exercises 7 through 10 on your homework. And so let's take a look at this. It says find the value of x. Well, this angle right here is obtuse. It is an exterior angle to the parallel lines, and it is congruent to angle 4 because they're vertical. And then angle 4 and this angle x plus 5 are consecutive interior angles or same side interior angles, and we know they add up to 180 degrees. So you can set this up as saying the measure of angle 4 plus the angle that's x plus 5 degrees equals 180 degrees. Okay, so because this angle here and this angle here are consecutive interiors and they are supplementary. One's obtuse, one's acute. They add up to 180 degrees by the theorem. And the measure of angle 4 is equal to 115 degrees because of vertical angles are congruent. So we'd say 115 degrees plus x plus 5 equals 180. Combine like terms and you get x plus 120 equals 180. And then finally subtract the 120 from both sides and we get the measure of, or the value of x. And that would be x equals 180 minus 120, which is 60. So 60 plus 5 is 65 degrees. 115 plus 65 is 180 degrees. So you should always check to make sure your answer is correct. And therefore, in this situation, the value of x is 60. Okay, example 3, using properties of parallel lines. After this example, you should be able to do your homework exercises 7 through 10. It says find the value of x. So this is very similar to the last problem. Well, this is 136 degrees right here. And as you can see, it's obtuse. So this angle here is also 136 degrees because they're corresponding angles. So this angle here and this angle being 136, then we have a linear pair. So this angle here plus this angle here adds up to 180 because it's on a straight line. So my equation is going to be 136 degrees plus 7x plus 9 equals 180. Okay, and 7x will be by itself. 136 plus 9 is 145 equals 180. I'm going to subtract 145 from both sides. So this is just basic algebra here. And I get 7x equals, and that's going to be 35. And divide both sides by 7. And I get x equals 5. So 7 times 5 is 35 plus 9 is 44. 136 plus 44 is 180. So my answer checks. So the answer is x equals 5. Okay, proving theorems about parallel lines. Yay, my favorite proofs. Exercises 15 through 18 can be answered after you watch this example. So here we go. It says proving the alternate interior angles theorem. Prove that if two parallel lines are cut by a transversal, so here's line P, here's line Q, they are marked as parallel in the diagram, and we have a line T that is a transversal cutting through them at these 2 points right here. Then the pairs of alternate interior angles are congruent. So what we're trying to prove is that angle 1 trying to prove that angle 1 is congruent to angle 3. No, we aren't. Angle 1 is congruent to angle 2. We were given that P is parallel to Q. So we start with our givens. So our statement's going to be P is parallel to Q, reason given. The next thing we're going to say is angle 1 is congruent to angle 3. So let me get these out of here. I only like to label my diagram as I'm proving them to be true. So I'm going to say angle 1 is congruent to angle 3. And when I look at that, I'm like, okay, the reason for that is that they correspond. Corresponding angles are congruent. So that's going to be my reason. Corresponding angles theorem. The next thing I want to say is angle 3 is congruent to angle 2. So now 3 is congruent to 2. And what kind of angles are those? Starts with a V. So reason number 3, vertical angles congruence theorem. Vertical angles are congruent. Okay, so now I've proved 1 is congruent to 3. 3 is congruent to 2. And if we cancel the middleman, as we say in class, get rid of these, then we can then state that angle 1 is congruent to angle 2. And the reason, transitive property of congruence. Okay, and so that is a quick, simple 4-step proof proving alternate interior angles are congruent. All right, solving real life problems. So after this example, you should be able to do exercise 17 from your homework. And example 5 says, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. So I'm going to label this 40 degrees. Okay, what is the measure of angle 1? Now notice this right here and this right here. That is saying that those two sun's rays are parallel, and this red line here is a transversal. So what is the measure of angle 1? Well, what I would say is the measure of angle 1 equals the measure of angle 2, because they're alternate interior angles, and alternate interior angles are congruent. So therefore, the measure of angle 1 is 40 degrees. Okay, and that's it. That's pretty short and sweet. Okay, that brings us to the end of chapter 3.2. And again, the problems that I assigned are down below. Have a great day.